Okay, let's go about writing our first Rust program. And what I wanted to do was also tell you that I recreated this code space after updating all the Docker file and things like that. So just out of the box, the Rust C-V should work. Okay, that's out of our way. So now let's go ahead and create our own Rust program. Okay, so the first thing to do is to create a file in which we are going to write Rust. So I'm just going to create a file at the root here, so you can also, simply do code main.rs. And main is, there's nothing specific or wholly about main as the file name here. It could just as well be, I don't know, rprog dot rs. And once you type that and hit the return key, a new file opens with rprogram or rprog.rs. The rs file extension is to represent Rust. Do we need a file extension? Well, let's play with that in a bit. All right, so now what we want to do is we want to start off by doing the hello world program. So in Rust, okay, few things. So in Rust, much like in C, but then in C, things are different. You can also start off without that specific function. Uh, but the entry function in Rust happens to have the name main. Okay, whether or not uh, that is a compulsion, we'll see. We'll discover that. But right now, for the Hello World program, let's just ahead with main. Now, main here, my intention is to have main as the entry point as the function, and the keyword to declare a function in Rust is fn. So if you say fn space something, that something will be treated like a function. A function is a collection of instructions, a recipe, so to speak. And in C, we used to C or, well, I don't recall which other language, C++. So in C++, we used to give here the return data type, the data type of the value that the function would return. In case of Rust, well, that's not required. Or at least right now, I don't know if that is required or not. Well, let me take that back. Is it required? No. Can we force it? Like, can we specify which data type? I believe yes. I'll need to revisit the documentation. But okay, so we have main, then open and close curly braces here, and then, well, sorry, open and closing parenthesis, and then open close curly braces. Anything within the curly braces is the function body. Okay, and then what we'll do is we'll do print ln exclamation mark. So turns out anything that ends or a name or a keyword that ends in an exclamation mark, that's called a macro in Rust. We'll talk about what macro is, when we come to it. But for now, you have this macro and then, a semicolon here. And then what we are going to do is we are going to say within double quotes, hello world, and then /n, right? And then let me go ahead and just return a 0 here. We'll see what happens. Rust is very brutal when it comes to doing compile time check. So, and it teaches you. So we just have to be open to learning. So then I go to the terminal here and then do rust c and then pass this rprog.rs, and it's compiling, and turns out there is an error. Why is there an okay? So it expects us to just return and not uh, let's see whether it compiles. Done. So what you should notice here is we have rprog.rs, and rprog is the binary it generated, right? So at this point, when we executed it, everything went well. It did not print any warnings or errors, and then it gave us this rprog dot well, rprog as the let's see, rprog as the binary. And I know it's a binary because it's a ELF executable and linkable file format. So 64-bit, blah, 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 all of that. Okay, good. So now we are going to do /rprog, and hello world. Looks like we don't need the slash n because it's going to print a line. And let's try doing few other things. So I'm going to remove the binary, so the binary is gone. And what I'll do now is change, okay, what is it? See text and images copied to the clipboard. Yes, allow. Okay. So I'm going to rename this to main.rs, being a little more formal about it. And then let's do Rust C main.rs. Okay, all good. We do slash dot slash main executes. Great. Hello world is here. What I want to do is also now remove the extension. Well, okay, that's going to be funny. So I'm going to delete the executable file and then rename the main to main dot to just main. And now let's see. This is going to be tricky. Rust C main. Ha. Main would be overwritten by the generator. Okay, so it did accept that file, the content of it. What it's saying is, hey, I'm also going to generate a main file, and that would then, overwrite your existing main. So that's a problem. So what I'm going to do now is to rename it to main.txt. And then let's see if main.txt, it accepts that. It accepts and it creates the main. And let's see, dot slash, dot slash main. Yep, hello world. Now the final thing, which is we'll um, name this as not main. So let me also rename this to rs so that the color, yes, so syntax is color. So I've renamed this function to not main, and I'm going to try and do rust c main.rs. Well, it it complains saying, hey, main function not found in the crate main. So it is treating this like a crate. Crate is equivalent of a module. It's along those lines. We'll talk about crate when we come to it. Consider adding a main function to main.rs. So the compiler is helpful here. It's guiding us as to what we should be doing. So the entry function here should be main. All right, we'll go ahead, compile that, done, execute, great. So this was then the hello world. If you're able to achieve this, your environment is perfectly set up and we are ready to do more experiments. And before I go, or before we conclude this lecture, see, we have executed the Rust compiler on this Linux machine, which is in the cloud code space, and so we have used the Rust compiler that's on this x86 Linux machine in the cloud, and we compiled this binary for the Linux operating system. Now, going forward, what we are going to do is we're going to figure out a way to actually boot up a CPU in an emulator. An emulator is a software that can mimic the CPU behavior. We'll talk about that. So we can use an emulator, boot up a CPU from scratch, and actually load just our Rust um, code on that CPU. So that way we will get to learn how to control the boot up sequence and how to land in the Rust code. All right, more about that in the future lectures. For now, let me catch you up in the next one.